History is often written by the victors, but in science it is written by those who fit the mold. For centuries, the mold was rigid, male, and fiercely protective of its boundaries. In the late 1960s, the night sky was considered the domain of men who smoked pipes and looked through the grand telescopes of Palomar and Mount Wilson, places where women were literally barred from entering because, as the absurd excuse went, there were no bathroom facilities for them. But history has a way of crumbling when faced with a mind that refuses to accept the impossible. In the shadow of these giants, a young astronomer named Vera Rubin was about to shatter the glass ceiling of the cosmos, not by looking for something new, but by looking at something everyone thought they already understood: the rotation of galaxies. The year was 1968. Vera Rubin, collaborating with the brilliant instrument maker Kent Ford, turned her attention to our neighbor, the Andromeda Galaxy. At the time, the laws of physics governing the universe seemed absolute. They were the laws of Isaac Newton and Johannes Kepler. Every astronomer knew that in a solar system, planets closer to the sun move faster, while those further out trudge slowly through the dark. Mercury races, Pluto crawls. This is the law of gravity. The farther you are from the mass at the center, the weaker the gravitational pull, and thus the slower the orbital speed. It was elegant, it was logical, and it was unquestioned. It was the bedrock upon which our understanding of the universe rested. Rubin and Ford weren't trying to break physics, they were simply trying to measure. Armed with Ford's cutting-edge image tube spectrograph, which could capture light from faint stars more efficiently than ever before, they peered into the edges of Andromeda. They wanted to map the rotation curve, the speed of stars at different distances from the galactic center. The expectation was boringly predictable, a curve that rose near the dense center and then dropped off steeply at the edges, fading into the blackness of intergalactic space. It should have been a simple confirmation exercise, a footnote in a graduate student's textbook. But as the data began to emerge from the darkness, the impossible happened. Rubin analyzed the spectral lines, the fingerprints of light that reveal speed. She looked at the stars on the very fringes of the galaxy, the lonely sentinels in the dark. They shouldn't have been moving fast. They should have been drifting. Instead, the data screamed. The curve didn't drop. It stayed flat. The stars at the edge were racing at the same breakneck speed as those near the blazing core. Rubin checked the numbers. She rechecked the equipment. There was no mistake. According to every known law of physics, Andromeda should not exist. At those speeds, with the visible mass of the galaxy providing the gravity, the outer stars should have been flung out into the void like loose stones from a spinning slingshot. The galaxy should have torn itself apart instantly. But there it was, majestic, stable, and spiraling peacefully. Rubin was staring at a violation of reality. She had found a crime scene where the laws of nature had been broken, or perhaps where the laws we knew were merely a localized illusion. She hadn't just found an anomaly, she had found a broken universe, and she was the only one brave enough to say it out loud.
When you eliminate the impossible, whatever remains, however improbable, must be the truth. Vera Rubin was left with two terrifying options. Option 1. Isaac Newton was wrong, and the fundamental theory of gravity that had guided science for 300 years needed to be thrown into the trash. Option 2. There was something else out there, something huge, something invisible. Rubin chose the latter, but the implications were staggering. For the galaxy to hold together at those rotational speeds, there had to be more gravity, much more. In fact, her calculations suggested that the visible matter, the shining stars, the glowing gas, the dust lanes, everything we had ever seen or touched or named, was merely a dusting of snow on a mountain of invisible substance. She realized that the galaxies were not defined by their light, but by their darkness. There was a halo of unseen mass enveloping the galaxy, clamping it down, holding the fleeing stars in a gravitational vice. She called it dark matter. The term had been whispered before by Fritz Zwicky in the 1930s, but he had been dismissed as an eccentric curmudgeon. Rubin brought hard, undeniable data. She claimed that 85% of the universe was made of this ghost material. Imagine the hubris of humanity, believing we understood the cosmos, only to be told by a woman in a basement office that we had only ever seen 15% of reality. We were effectively blind. The scientific community, predictable in its arrogance, did not roll out the red carpet. They rolled their eyes. The pushback was immediate and patronizing. It must be the equipment, they said. Rubin is misinterpreting the spectra, they whispered in faculty lounges. It was easier to believe that a woman had made a mistake than to believe that the universe was filled with invisible ghosts. They wanted her to be wrong. It was uncomfortable to admit that the solid universe was actually mostly empty space filled with a mystery that emitted no light, cast no shadow, and interacted with nothing but gravity. But Vera Rubin possessed a weapon stronger than theory: persistence. She didn't stop at Andromeda. She turned her telescope to another galaxy, then another, and another. She observed over 60 spiral galaxies, and the story was identical every single time. The rotation curves were flat. The ghosts were everywhere. The data became a mountainous wall of evidence that no amount of skepticism could scale. This was not a glitch. This was the architecture of the cosmos. Rubin had effectively discovered the scaffolding of the universe, the invisible skeleton upon which the galaxies were draped. She had proven that we are the anomaly, that normal matter, the stuff of atoms and life, is just the rare foam on top of a deep, dark ocean. She forced the establishment to look into the void and admit that it was full. By the early 1980s, the war was over. The Rubin-Ford effect was undeniable. Dark matter moved from the fringes of heresy to the center of every cosmology textbook on Earth. The paradigm had shifted. We were no longer living in a universe of light, but in a universe of dark matter and dark energy. Vera Rubin had fundamentally changed the human understanding of our place in existence. In any just world, this is the moment where the story culminates in a phone call from Stockholm. This is where the gold medal is placed around the neck of the pioneer. But the phone never rang. Year after year, October would arrive, the season of the Nobel Prize, and year after year, the committee announced the names of men. Some were brilliant, certainly, but many were awarded for discoveries far more specific, far less foundational than the discovery of the majority of the universe's mass. Men were awarded prizes for finding new subatomic particles, for improving lasers, for theoretical models of exotic states of matter. Meanwhile, the woman who had effectively found 85% of the universe was met with a deafening silence. It became an embarrassing ritual in the scientific community. Every year, articles would appear. Is this finally Vera Rubin's year? And every year, the answer was no. Why? Was it the lingering bias of a committee that had historically overlooked women? Was it a refusal to award a prize for a discovery that was technically an inference, since we still haven't captured a particle of dark matter? The excuses were thin. Penzias and Wilson won the Nobel for discovering the cosmic microwave background, evidence of the Big Bang, without fully understanding what it was initially. Rubin had provided the evidence for the composition of the cosmos, yet she was left standing outside the Hall of Fame. Vera Rubin died on December 25, 2016. The Nobel Prize statutes strictly forbid posthumous awards. With her death, the committee's opportunity to rectify their 4-decade mistake vanished forever. They had waited her out. The ultimate recognition was withheld, perhaps because she didn't play the political games, or perhaps simply because she was a woman who dared to tell the men that their math was broken.
But if you look at the legacy she left, the lack of a medal feels almost irrelevant, a stain on the committee rather than on her. Today, a new generation of astronomers is building the most advanced telescope in history, a wide-field survey telescope that will map the heavens in unprecedented detail. It is not named after a king or a donor or a man. It is the Vera C. Rubin Observatory. It is the first national U.S. observatory named after a woman. While the Nobel Committee erased her from their lists, history has carved her name into the bedrock of the mountains and the stars themselves. She didn't need their gold. She had already given us the universe.